Welcome to Section 2.1, Functions and Their Graphs. We're heading towards the end of Unit 1 here. It's only this section and one more section on step functions before we get to our Unit 1 test. So if you're still running into some issues, make sure you're coming in. But to the subject at hand here, identifying a function, we take any equation. It's called a relation between the input values. So any equation we ever work with is a relation between input and output. Input being our x values, and output being our y, sort of like a factory. You start with something, you put it in, something comes out. Sort of like the example, if we have y equals 2x, we input 3, we substitute 3 in, then our output is 2 times 3, which is 6, which is our y value. So, kind of definitionally here in our math lingo, a relation is the relationship that your input and your output have. Again, your input being x and your output being y. Within that, you have what's called a domain and a range. Your domain is all possible x values in a relation. And sometimes they may be limited depending on what the equation is. Okay. Your range is going to be all possible y values in a relation. And again, that depends on what you're working with. And then if the relation is a function, which is what we're going to be talking about being able to identify today, in that case, there's going to be exactly one output, one y value for each input, each x value, one for one. I plug one number in, I get one number out. Not like I plug one number in, I get 3 numbers out. That's not how it works. So, for our examples here down below, identify the domain and range, then tell whether the relation is a function. Okay? My domain is my input values. Now when we go to list these, okay, this is what's called a brace. It's not a parenthesis. It's not a bracket. Those are used for a different purpose. The brace, I always used to call this Jay Leno. I don't even know if people know who Jay Leno is at this point. We've got the big forehead, the little pointy nose, and the big chin here. So we get our brace working, and we list the x values from least to greatest. Okay? For range, we do the same for our y values. And again, order them, please, from least to greatest. Because mathematically, it's just a thing to do. And then to tell whether the relation is a function. Well, this time, the answer is going to be no, and here's why. Because we set up above, there's exactly one output for each input. For every x, there's only one y value. Well, for this particular x, there's 2 y values. Okay, there's 2 outputs for one input. So that doesn't work. Okay? Cannot have one x value giving me 2 y values. Number 2, though, same idea. Least to greatest. Range. Least to greatest. Now look this time. Now some of you may be saying, well, no, it's no again. Well, this time I disagree with you. It's yes. You're like, but there's 2 arrows going to the same number, just like before. But there's a difference. Remember, the rule is 1 y for each x. 1 y for this x. Okay? 1 y for this x. 1 y for this x. Even though they get the same value, it's a 1-to-1 relationship. Here it was 1x, 2 y's. Here it's 1x, 1y, 1x, 1y, 1x, 1y, 1x, 1y. Okay? So they all are 1 to 1. And that's why that's a function. Okay? Now, that's if I have all the values listed. Well, what if I don't have the values? What if I have a picture instead? Then we have a test that we use to determine it. It's called the vertical line test. Now, which direction does a vertical line go? Right, up and down. I wish the old Mountain Dew commercials were still on, where they used to go, get vertical, get vertical. Okay, I'm sorry, I'll try to avoid singing here. But it's because they were doing like skateboarding and jumping with bikes, and they'd go up in the air, up and down real high, which is a vertical line. So, it's only a function if it's only one point. So if we look up here, find the domain and range for each graph. Are they functions? Now here, it starts changing a little bit again. Let's do the easy part first. Are they functions? You're going to draw a vertical line somewhere through, and you're not looking for an exception. You're looking for somewhere towards the middle. And you're going to look and you're going to say, okay, how many places does it cross? So it crosses at 1. So is this a function? Yes, it only crosses at 1 point. Domain and range. Up above we used braces because we had individual values. Now, when you're looking at a lot of values. I mean, there's a lot of values along that line. We don't want to write every single one of those out. So here's how this works. Again, my domain is my x values. We're going to work from left to right on the graph. Well, where's the leftmost point of my graph at? Here at -6. So let's just write that for now. Where's my furthest point to the right? Over here at +6. Here's how this one's going to work. We're going to put a comma in there. And since there's dots at each end, we want to include those. And we're going to use a bracket. A bracket means you include the endpoints. You're like, now, why are you doing that again instead of just writing down, -6 to 6, or just writing -6, -5, -4? Because all of the decimals and fractions that are in there, too, as I work my way along the function, need to be included. This interval notation tells me that I want every single value for x between -6 and 6 because they're all accounted for. There's no holes in my graph or anything like that. Range, however, same idea. It's my y values. Now I'm going from down to up. What's the lowest point on my graph? Here at -3. Where's the highest point? Up here at +4. But that's how we write interval notation on functions. Okay? Use the vertical line test to figure out if it's a function, then do your domain and range from there. So if we're taking a look at number 2 then, let's say. And again, just pick a spot somewhere central for your graphs. I'll pick the y-axis here. Only 1 point. Function's a yes. Okay, now remember, domain, we're going left to right. For this point left, x value-wise, -7. To the right, +6. Always using the brackets here. Range, lowest point according to y, 1. Highest point according to y, 8. Then we're ready to flip to the other side in this case. Alright, let's take a look at number 3. Again, just find a somewhat central place in your graph. Draw your vertical line. Ooh, 1, 2 points. Is this a function? No, because it crosses at 2 points. In other words, for one x value, I have 2 y values, which is why this isn't the case. Okay, domain, still working left to right. For this point left, looks to be somewhere in the ballpark of maybe 4.5. Furthest point to the right looks to be about 7. And again, down to up for range. Lowest point looks right around -2. Highest point looks right around +2. And it works that way. So then we start throwing a couple of twists at you. Number 4, what looks different about number 4 versus the other ones we've done so far? Got arrows on the end. We'll talk about that in a minute. Okay, let's say we draw our vertical line through. Still only looks like it's 1 point. So that's a yes. Now here's something we need to note here. You see arrows. Arrows are infinite. They go on forever, not just that point where you see them on there. So this arrow that you see here is actually continuing to go on and on and on right off the screen. Okay, here, on and on and on right off the screen. So when I start thinking about domain and range, I got to think much bigger. We're like, well, furthest point to the left, it's still going. It's right off the page. Right. What do we call it when it goes forever in some direction? Infinity. Now, infinity does not get the bracket because we don't have an endpoint to stop at that we can include. It just goes. Well, if it goes forever to the left, it also is going to go forever to the right because off it goes here. So negative infinity to infinity. Now, what about the range when we go down to up? Well, there is a bottom point here. Looks like where y equals 0. It's right on the axis. So that still is going to get the bracket. However, when we start going upwards, up here we go again. Up, 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 up. Goes forever. Infinity. Okay, so the arrows give us a particularly more interesting little way of going about things. Okay? Let's move our way down. We're going to skip around a little bit here. We're going to look at 6 and 8. Might squeeze 7 in here. We'll see. Okay, 6. Is it a function? Yes. I mean, you can look at this point and see it's only going to go through one place. So domain, left to right. We have an endpoint on 1 point. So negative 5. That's okay. But as it goes, this arrow is going to keep going and going and going and going. So we can have infinity with a number. Okay, what about my range? Well, the lowest value looks like it's right here about negative 3. But it's going to go up, 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 up forever. And that's just kind of the thinking process we're starting to do with these. Same thing when we're looking at a problem like, I don't know, let's say number 8. Okay, number 8. If I drew my line through 1, 2 places, functions in O, domain, furthest to the left, these arrows are going to keep going, 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 going. Looks like a negative infinity, and yes, that matters. If it's going to the right, it's positive infinity. If it's going to the left, it's negative. Something you have to watch out for. So here, but what about when I go to the right? Well, it looks like it gets to about 4 and stops. Okay, if you wrote 3.5, that'd be okay too, as long as you're in the real close range here. Now range, what about that? Well, this goes forever, down, 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 down. This is going to go forever, up, 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 up. So the negative infinity and beyond. Oh, wait, that's a movie. That's not math class. But with this, you have a worksheet to work on, some of the similar type things, especially getting used to what domain and range are the big things here. So, as always, if you have any questions, let me know. Good luck.